Okay, next problem, we're going to look at example 2. And this will be the cosine function. So here we start with the cosine. And from it, we can get to the inverse cosine. Let's see. A little bit of a slowdown here. Leg. Okay, we're going to look at this function. And just like with the sine function, this function, in order to create the inverse, it is the domain is restricted from 0 to pi. And notice we have one piece of the sine function here, the cosine function, and that's all we need, full range of values from -1 up to 1. And that will give us everything we need from the range of the cosine, and also restricting the domain so that we do have a decreasing function. It's monotonic, and it means it'll be 1 to 1. And that means it'll be the inverse will be a function. So this is the cosine here. That's the cosine of x. And over here now, we're going to take a look at the inverse cosine. So what happens is that we're going to see something that looks more like this. Okay, and that's from low point to the high point. So these points, again, the x and y values are interchanged. And this point here, let's just take a look at what happens to a few points. This point, which is 0, 1, becomes 1, 0. It's over here. This is the inverse cosine. Okay, so the 2 points, this one over here, which was, this one, which was 0, 1, became 1, 0. Let's look at this point here in the middle, which is pi over 2. Pi over 2, 0 becomes 0 pi over 2. So that's the point right here, 0 pi over 2. And then this point over here is -1 pi. Okay, so when we answer questions about the inverse cosine, we're trying to find, for example, let's start here, x and the inverse. So on my chart, I have -1/2, 1/2. Root 2 over 2. I've got a 0. And I also have a -√3 over 2. Okay, so let's do the first one here. We want to find the inverse cosine of a -1. Well, you have to ask yourself what angle, when you find the cosine of that angle, would give you a -1. Well, we know our cosine. We can look at our unit circle if we want. We know that happens at pi. The cosine of pi is -1. Same thing here, we want a half. Well, this would be the cosine of pi over 3. So the inverse cosine, so this first one here was pi. Next one, 1/2 would be pi over 3. And third one here, root 2 over 2. We're familiar with the unit circle, so you know that this would be a pi over 4. When is the cosine 0? Here, when is it 0? That's what you're asking. When is the cosine 0? Well, you know it happens at pi over 2. When is it -3 over 2? Well, you know, the first place that happens is going to be pi, well, we'd be all the way at what, 5 pi over 6. Again, you have to look at the unit circle for that one. But if you were working on the unit circle, you would see a triangle. It looks like so. And back over here. Okay, so the triangle looks like so, which would give us our root 3 and the 1 and the 2 like that. So you can see that our angle would have to be a 5 pi over 6. The reference angle down in here is pi over 6. And here's our triangle. So if you had the unit circle in here, you could do that quickly. So that's your answer for that one. The inverse cosine of a -3 over 2. Oops. Is 5 pi over 6. Now you notice every angle that we used here, every number that we returned into the range had to be between 0 and pi. In here, all these numbers that we chose had to be between 0 and pi, because that's the range that we have to work with our restricted domain for the inverse cosine from 0 to pi. So all of our answers need to be between 0 and pi. You know there are other angles where we get these same cosine values, but not when we're working with the inverse cosine. It has to be restricted.